morning, Chem 1. Today we are going to proceed through Unit 12. We're going to look at some phase diagrams, which should not take too long. They're pretty straightforward. Just some interpreting of graphs that'll take place today. On Friday, you will have a note video as well as a quiz. All right, I will post them both. The note video will be short. The quiz will be kind of like taking into account this whole week. I think you'll be fine. It won't be a ton of time, but I'm just letting you know ahead of time that this week we're going to try to get some more information done. We have, I know it doesn't feel like it yet, but the end of year is coming, and we're trying to make sure we cover as many of the basics as we can, so that when at whatever science class you're going on to, you have what you need. I'm recording this on a Monday. I had a good weekend. My wife and I, she goes online and she'll see things on Pinterest or wherever, like, oh, like, hey, I think we could do this. And when she says we can do this, she means like I can do this. She like makes me like make all this stuff, and she thinks I'm good at it, but I'm not. And so we made 2 end tables for our living room. They look pretty good. And one has a little lean to it, but it's okay. It'll work. We haven't painted them yet, but it was fun. It was a good time. I'm expecting a call from HGTV. Chip and Joanna Gaines going to call me here pretty soon. Probably get me on their show. Show them how to do some things. I'm pretty handy. Know my way around a garage because I'm a man. So no, we'll see. We're going to paint them this week and stain the top. So we'll see how they turn out. I'll show you pictures when they're fully complete. But right now, my kids, they see us building things and they want to like use power tools to build themselves a treehouse. If you see me on the news, you'll know that'll be why. Hopefully we can keep them away from the power tools. Okay, let's talk phase diagrams. 12.6. At this point in time, we've talked about how energy goes into and out of substances, and this can cause phase change based on the strength of the intermolecular forces, and if the energy that's added to those molecules is great enough, they will spread out and they'll go from solid to liquid to gas. So across the top here, okay, we are adding energy, so these would be endothermic. Okay, melting is endothermic, evaporation is endothermic. Why? Because we're adding energy into the substance and they are spreading out with speed. In this situation, going from gas to a liquid and then to a solid, these would be exothermic, because in order to make a gas turn into a liquid, we need heat to leave that substance. Okay? And same thing if we're going from a liquid to gas. So freezing condensation would be exo, melting evaporation would be endo. And we, at this point in time, if you remember way back in the first semester, we talked about phase diagrams where we would show the gradual temperature change over time. And whenever that line would level out, that would tell us when the melting point and boiling point would occur. And we were looking for that leveling of the line, and that's when you have a phase change. So with this, we just kind of covered this already. But endothermic changes would require energy, and therefore would be going up. Okay, so melting and vaporization. And sublimation, that's when we go from a solid to a gas. Okay, and then exothermic is when we go down, we want to lose heat. Freezing, condensation, deposition, this is when we go from a gas to a solid. Okay, but just know the difference between those two. But what we've learned at this point in this section, okay, with gases and liquids and solids, is that phase changes can occur not just with temperature change, but also with pressure change. So when we say melting point or boiling point, we are talking specifically about standard temperature or standard pressure. So the boiling point of water is 100 degrees Celsius, but only at 1 atmosphere. If the pressure changes, that's going to change the atmospheric pressure over top of the liquid, and therefore change the pressure that's pushing down on the liquid, and therefore change the temperature at which it boils. Okay, because boiling is literally the vapor pressure of the liquid overcoming the downward push of the atmosphere. All right. So what that means is it's not just a temperature change that determines a phase change. It's also a pressure that determines a phase change. We have to look at the temperature and the pressure. So what this chart is showing, standard pressure is right here at 1 atmosphere. And what this is showing is at, let's see, we got 273 degrees Kelvin, which is 0 Celsius. That's when this substance goes from a solid to a liquid or melts. And then at 373 Kelvin, which is 100 degrees Celsius, this substance goes from a liquid to a gas. Okay, this line is showing the boundary between liquid and gas. So what do you know that has a melting point of 0 and a boiling point, liquid to gas, of 100? It would be water. So this is what we call a phase diagram for water. Notice that as the pressure goes up, that slightly changes the boiling point, and it's going to slightly change the melting point, and slightly change the boiling point. All right? Understand that the work with these a lot of times is going to be an unlabeled one, and you're going to try to pick out some of these pieces and parts. Notice the solid to liquid barrier and the liquid to gas barrier will always be in this orientation. Solid will always be at the coolest temperature. That makes sense, right? And then gas will always be at the highest temperatures. There's some other points on here we'll point out here in a second. But knowing that this is going to read solid, liquid, gas from left to right will be helpful. And that your boiling point, melting point, and freezing point, all those things will be right at 1 atmosphere. All right? So let's talk about a couple other items on this chart. So the first thing we're going to talk about is the triple point. The triple point exists when you have all states present at one time. So what's happening here is solid, liquid, and gas would be at this pressure and at this temperature would all be kind of like hopping in and out of that solid, liquid, gas phase. And you can find, I will link a video to this assignment so you can see what one looks like, because you can do this with like cyclohexane and some other things, and you can get at this triple point. It's really weird because it goes like solid, liquid, gas, and you could just see the phase changes like really fast. It's kind of interesting. Okay, what that means is that there is a place down here that goes straight from solid straight to gas. What's that called? Sublimation. Okay. So sublimation is anywhere below this pressure for this substance. All right. So, and if we go from gas to solid, that would be deposition. But this is the critical point. If we could get a pressure right at 0.006 and a temperature right at 273.2, we would have all three phases of this substance. The critical point, so we could label that TP, triple point. The critical point is right here, CP. And the critical point is the point at which it doesn't matter how much pressure you add, because the temperature is so high, those molecules have so much energy that you're not going to be able to basically pull them back in to a liquid. Okay? So in other words, if I heat this substance up to 647 degrees Kelvin, anything above that, it doesn't matter how much pressure you add, you're not getting it back to a liquid. Okay? Meaning that everything past this critical point is gas. Everything. All right? The higher the critical point, the weaker the attractive forces, and the substances are said to be difficult to liquefy. So 647 Kelvin's pretty hot. Okay? There's things with higher melting points than that. Or excuse me, vaporization points. All right, but just know that the weaker the attractive forces, it's going to have a higher critical point because it's going to be harder to bring it back to a liquid. These can also help us tell the density of a solid. Typically, the solid is more dense than the liquid, and what will happen is this will have a positive slope. So if you look here, This right here is typical. This line between solid and liquid is a positive slope, meaning it's going this way. Okay, if you remember your geometry or math or whatever that is. Okay, and so this is more dense than the liquid. That is typical. All right. Water, though, we know is less dense than the liquid because of the way it crystallizes. We would call this atypical. Okay, and the slope of the solid liquid line is negative. And because of that, it tells us that this is more dense. All right, you probably aren't going to get a question on this on a quiz. This is what I'd call a more specific question, and we would cover it more if we were in school together. But just to expose you to the slope of that liquid solid line can determine the density comparatively of a solid to a liquid. So that's pretty much it. So what we can do now, what you'll be doing on a quiz is I will give you a graph or I'll give you a phase change diagram. We call these phase diagrams, and your job will be to just kind of answer some questions about what's going on there with the basic background you have. So it says, what is the normal melting point? So you got to really think about what that is. Melting is when we go from a solid to a liquid. So it's somewhere along this line. And normal is telling me that we're at normal pressure or standard pressure, which is 1 atmosphere. So it would be right here. So we'd follow down and we'd say that's at 60 degrees Celsius. All right, sometimes you can see how these are in Celsius. What is the normal boiling point? First question, what's boiling? It's when we go from liquid to a gas. 1 atmosphere is standard pressure. We come across, it's about right there. So that would be 100 degrees Celsius. All right, which phase is the most dense? Well, we'd look at our solid liquid line, which is here, and see that it's positive. So that means that it's normal, and the solid phase would be the most dense, which is what we'd expect. What is the triple point? That's the point at which all phases exist, which is here. So we'd have 0.5 atm and 45 degrees Celsius. Notice we can't just say 45 degrees Celsius. It requires you to record, like with the normal substance, I can just record the temperature because it's assumed that we're at the standard pressure. But the critical point, you can't just say 45 degrees because that 45 degrees is anywhere on this line. Where? 45 degrees, right? You got to explain as in both axes. Critical point is here. It's the point where we can't compress into liquid anymore. So that would be 110. It looks like 110 degrees Celsius, and I would say we're probably at like what? 1.2 atmospheres? Maybe 1.1. Okay. If a substance at 20 degrees Celsius and 0.2 atmospheres is heated to 90 degrees, okay? So we're here at 0.2. So I'm going to say like right here, that's our pressure. And we're going from 20 degrees Celsius, which is probably about right here. Okay, I'm estimating. To 90, which is about right here. So we're going from here to here. What phase change occurs? So we are starting in section A. That's a solid. And we're ending in section B. This is the gas phase. So we went from a solid to a gas, and that is known as sublimation. So you still need to know the names of your phase changes. All right. So next one here, if we have a substance at 80 degrees Celsius, okay, we're at 0.8 atmospheres. So here, 80 degrees Celsius, and we go back down to 60. Okay, so we're going this way. So we went from a gas to a liquid. What's that called when we go from a gas to a liquid? That is called condensation. Right? So you need to know the names of your phase changes because you'll have questions where I'll say if you go from here to here, what phase change is occurring. But honestly, this 12.6 is just about looking at a graph and being able to interpret it. There's a lot going on that graph, but it's nothing you can't handle. All right? That's it for today. There's some activity questions that you can do that might help you prepare for the quiz this Friday. But feel free to do those, and we will see you again Friday with a short note video, kind of like this one, and a short quiz. We will see you then. Be good to somebody today.